So, we are here in section 5.3. We have 3 sections left to be done. I'm very excited about it. Learned a lot. I did another section off stream. Yeah, can I turn this down? How do I turn this down? Ooh, I can turn this down. Fantastic, which means that I can make this go up. And let's do... boy, I know you're not trying to get into that food. All right. Bot bricks. I don't know what that is. I need to double check. My chat and everything's so like screwed up and messed up and stuff because like I set it up when I didn't really know what I was doing. Anyway, let's see how loud this is. Wow, it's still really loud. Interesting. I don't know how to control that. Other than it going through a different thing. Well, we'll just stop it. I guess we don't need background music. Let's do a sound check of this stuff. Come on, dude. Do the thing.
What might be a symptom of a malicious attack on a DHCP server?
Okay, that's actually really loud. Let's turn that down just a little bit. All right, let's go ahead and get started here. What might be a symptom of a malicious attack on a DHCP server? So we are looking at scenarios, troubleshooting, common issues with network services. So frequent IP address changes, decreased number of DHCP requests, increased network speed, address pool exhaustion. I'm going to say it's probably address pool exhaustion because if it's been maliciously attacked, it probably doesn't have a lot of IP addresses. Yeah, okay, there we go. Cool. And remember, as we go through this, the first one that we go through, we're not really going to put any hard answers unless it's just like glaring. And we're doing that so that way when we come back to review them, we can review all of the answer choices as well. So we can get as much bang for our buck out of each question because we're trying to learn. All right?
A network administrator is testing a remote server's network configuration and decides to ping the Internet Protocol IP address of a familiar Office Windows workstation. No replies are received, but the admin confirms DHCP settings are enabled on the workstation and can successfully browse the Internet. What is the most likely reason why the client workstation did not respond to a ping request?
The IP address has expired. That doesn't make sense. Okay, if the IP address had expired, it wouldn't have access to the WAN. The Internet port is bad. Possibly. The same IP address of another client is being used. Could be, but that's not going to be a DHCP server. That's going to be a NAT issue. An IP address from another subnet is being used. Interesting. So it has access to the WAN, but it doesn't have access to someone else. I'm going to say that the Ethernet port is bad, but I'm not 100% sure. Okay, so then it has to be, it probably has something to do with the subnet mask or IP address of another client is being used. That one doesn't quite make sense to me, but since it doesn't make sense to me, it probably is the correct answer because it's something I don't know.
A user installs a financial software package that requires cloud access. For some reason, the application fails to connect to the cloud server. What is the most likely cause of this issue?
I just had an idea that I could change this to here, and this could play the music in the background. And then I could just make it really... Oh, no, because it's going to pick it up to the desktop. Dang it. No, it's still going to pick it up. It's because the desktop's the issue. Okay, don't worry about it. No music. Okay, I'll worry about that off stream. All right, let's see what's going on with this.
A user installs a financial software package that requires cloud access. For some reason, the application fails to connect to the cloud server. What is the most likely cause of this issue?
Okay, so the user has installed financial software and it requires the cloud access. Okay, so it requires internet access basically. For some reason, the application fails to connect to the cloud server. Duplicate IP, no. Unresponsive service, incorrect time, incorrect host-based and firewall settings. Probably incorrect host-based and firewall settings because, well, it doesn't say that it's able to connect to the WAN. For some reason, the application fails to connect. No. Okay, I'm assuming it's connected to the WAN because it's saying that the application has failed to connect to the cloud server, not the actual internet. So we're going to go and we're going to say that it's incorrect host-based firewall settings. Something is stopping it. The only reason that this might be wrong is that it might be on the other end, but most likely it's the company end. Ooh, let's go. Okay. What happens when topology changes notifications? TCN is received in a network using STP. This is going to be a really hard one because I do not know what STP is. So we're just going to hit straight up. I don't know. All right. Let's look at this.
In a newly set up branch office, a network administrator configures the network with the subnet 172.16.0.016. All devices are supposed to communicate within this subnet. However, the administrator notices that host X, with the following configuration, cannot access the shared resources located on a server within the same subnet.
Okay, so what is the primary reason for host X inability to access the shared resources? So it has an IP address. Ask the default gateway. Okay, first glance, everything seems fine. I do see this looks weird. Okay, the server IP address is in a different subnet. Yes. See, this is what's making me think that it's in a different subnet. The IP address is incorrectly assigned. That could also be the thing because that's basically the same answer, right? It's just a matter of which one's more correct. The subnet mask is too restrictive. Should not be. Okay? I need to get better at being able to do subnetting in my head. The default gateway is misconfigured. No. No, the default gateway is not misconfigured. I'm going to say it's one of these two. Dang! Okay. We're going to do... We're going to do this real quick. Application audio. Chrome. Okay, let's see if this works.
Recently booted computer systems at a large company are not able to access any network resources. IT investigates and finds the systems configured with automatic private IP addressing APIPA addresses. Which of the following is most likely causing the issue?
Okay, perfect. Wow, that really captured a lot. Holy crap. Let's do another one. Chrome GPT. Bet this is it. Okay. Little test.
Excellent.
Oh. It still picked it up on that side. That's weird. Okay. Well, that's what I get for trying, right? All right, let's look at the thing for real. I just wanted music in the background that wasn't like crazy overpowered. I just can't control it, you know?
Recently booted computer systems at a large company are not able to access any network resources. IT investigates and finds the systems configured with automatic private IP addressing APIPA addresses.
Ooh.
Which of the following is most likely causing the issue?
We got a peepa. A peepa. Okay, expired IP addresses, most likely. Incorrect network mask, probably not. Exhausted IP scope, that's also possible. Unresponsive services. So it's either... It's one of the two. Recently booted computer systems at a large company are not able to access the network. I'm going to say exhausted DHCP scope because it says that it's a large company, and a large company is going to have a bunch of IP addresses, and I bet you, because it also says that they're recently booted computers, that it put too much of a strain on the scope, meaning the amounts of IP addresses that they have. Ooh, I'm correct. Okay. I can't believe that didn't work. Hold on. I really want to try this again.
Users are reporting that they are
Okay.
unable to access the
No. It's picking up the same Chrome tab. That's wild. Well, then that shouldn't matter. Okay, what about now?
the company's shared drives within the
Okay, perfect. And then if I go and turn this on. Okay. Now we have some background music. How loud is that? Is that too loud? Find out. Turn it down just a little bit, and then we'll do another test volume.
in the corporate wireless. However, if they are hardwired, they can access the shared drives.
Okay, I think I figured it out. Now we have some music going on. You gotta have the jams. You know what I'm saying?
Users are reporting that they are unable to access the company's shared drives within the corporate wireless. However, if they are hardwired, they can access the shared drives. What is the most likely reason that they are having issues accessing the shared drives?
So if users are reportedly they're not able to access the shared drives within the corporate wireless. However, if they are hardwired, they can access the shared drives. So that means that something is going on with, I don't know if it'd be attenuation. That is signal degradation. But it could be signal degradation through the Wi-Fi. Probably not DNS issues. I can't imagine how it'd be a DNS issue if they're able to connect to it through the hard line. It sounds more like a signal, like there's something wrong with the Wi-Fi. Now, I don't know what site survey is. I kind of understand what baseline is. Okay.
You are configuring a new network segment that includes 3 switches, switch A, switch B, and switch C.
Okay.
Switch A is connected to switch B is connected to switch C, and switch C is connected back to switch A, forming a triangle.
Okay.
To prevent loops, you decide to implement the spanning tree protocol STP.
Okay, so STP means spanning tree protocol. We're gonna have to look that one up. I think I know what that is. I kind of remember spanning tree protocol, but I don't remember it being called STP. Some of these acronyms, man, they kill me.
After enabling STP, you notice that one of the links between the switches is not forwarding traffic. Which of the following links is most likely to be in a blocking state due to STP?
Let's see if we can use our deductive reasoning skills. Any of the links could be in a blocked state depending on the bridge ID. The link between C and A Hmm. I don't know. I don't know. Let's learn. Okay, let's look at this one. The answer for this...
A network administrator is testing a remote server's network configuration and decides to ping the Internet Protocol IP address of a familiar Office Windows workstation. No replies are received, but the admin confirms DHCP settings are enabled on the workstation and can successfully browse the Internet. What is the most likely reason why the client workstation did not respond to a ping request?
An IP address from another subnet is being used. Interesting. An IP address from another... Okay, let's see what we got.
The client workstation has a valid Internet Protocol IP address from a different subnet range. This is possible with a rogue dynamic host configuration protocol DHCP server on the same local area network LAN.
I don't fully understand.
The client workstation has a valid Internet Protocol IP address from a different subnet range. This is possible with a rogue dynamic host configuration protocol DHCP server on the same local area network LAN. Windows client workstations with duplicate IP address will have disabled network services. It will stop network communication and possibly even prevent browsing the Internet. An expired IP address will continue to try and request a new address from a DHCP server. Since the workstation was able to browse the Internet, its IP address lease is still active. A bad network or Ethernet port on the client workstation will most likely prevent any communication going in and out. This is not the case here. Additional learning.
Okay,
Previous
so that makes
back to
sense.
review. Review correct answers next.
Okay, that makes sense for why it's not the answer that I said. Because it can reach something. Because testing remote server network, it's supposed to ping. They cannot ping, no replies received, but the admin DHCP server settings are enabled for the workstation. Oh, and can browse the Internet successfully. So that makes sense that it's one of these two. What I don't understand is what the difference between these two are and what they mean. Let's see what ChatbotGPT has to say.
Great question to kick off section 5.3. Let's break this scenario down clearly using your 5-part format. Question: a network admin tries to ping a Windows workstation's IP but gets no reply. The workstation can access the Internet and has DHCP enabled. What's the most likely reason it doesn't respond to the ping? Correct answer: an IP address from another subnet is being used. 1. Restate the question. Why would a Windows workstation, which is actively browsing the Internet and has valid DHCP settings, fail to reply to a ping from a remote server? 2. Simplified answer. The server is on a different subnet, and Windows by default blocks ICMP ping requests from other subnets. 3. Analogy. Think of it like trying to knock on someone's front door, but their doorbell ignores visitors from outside the neighborhood. Inside the neighborhood, same subnet, the doorbell rings. Outside, it stays silent, not because no one is home, but because they're ignoring strangers. 4. In-depth explanation. Windows client machines, especially modern versions like Windows 10, 11, often block ICMP echo requests pings by default, especially if the request comes from a different subnet or network zone. Let's look at the logic.
Okay, I'm having a hard time grasping this. Let's go back to 2.
DHCP is working. The machine can browse the Internet. 2. Simplified answer. The server is on a different subnet, and Windows by default blocks ICMP ping requests from other subnets. 3. Analogy. Think of it like trying to knock on someone's front door, but their doorbell ignores visitors from outside the neighborhood. Inside the neighborhood, same subnet, the doorbell rings. Outside, it stays silent, not because no one is home, but because they're ignoring strangers. 4. In-depth explanation. Windows client machines...
Servers on a different subnet. See, what I'm having a hard time is every time I think I understand what a subnet is, I'm quickly proven that I don't know what a subnet is. So for me, what it sounds like a subnet is an IP address that has been broken down into more small layers. And they're also grouped together. But I don't know if that's necessarily it. Maybe this is the moment to dive into it to figure out what the thing is.
Subnet.
Oh, dang it. Let's look at this analogy
3.
again.
Analogy. Think of it like trying to knock on someone's front door, but their doorbell ignores visitors from outside the neighborhood. Inside the neighborhood, same subnet, the doorbell rings. Outside, it stays silent. Not because no one is home, but because they're ignoring strangers.
Also, okay, I do know that a subnet has to do all internally. Like, it's all private. So it would make sense that you would have access to an internet browser in the WAN and not be able to do the subnet mask. So the question is, okay, let's look at the more in-depth answer here. So my issue is that it says an IP address from another subnet is being used. What does that mean that another IP address from another subnet is being used?
4. In-depth explanation. Windows client machines, especially modern versions like Windows 10, 11, often block ICMP echo requests pings by default, especially if the request comes from a different subnet or network zone. Let's look at the logic. DHCP is working. The machine can browse the internet. You're not getting ping replies. Most likely culprit? Firewall settings that block ping ICMP from other subnets. The Windows Defender firewall has rules like allow ping from same subnet, block ping from different subnet. You could still RDP.
Now, why would it do that? Why would it block pings from another subnet if it's all within the same intranet? Like the same closed thing. Like why would it do that? Just to like stop traffic? To cool down on traffic? Okay. Let's type that down. I am still having a hard time understanding subnets. It's broken down into basically more lines, so that way you can use the same IP address for multiple devices, but they are grouped together. I don't think that this is right. Grouped together. I can't talk and type at the same time. Sorry, boys. I'll try to be better. I also know that sometimes subnets are used to group offices and departments together to make it easier. So why would what did it say? Why would ICMP block pinging from another subnet? Why would that matter? Why would that matter if it's all within the same private network? Like, say, a company or something. I guess I am not understanding the core of what subnetting is and why we do it. Okay. I'm sure that there's more questions that I have, so let's go back.
From other subnets. 3. Analogy. Think of it like trying to knock on someone's front door, but their doorbell ignores visitors from outside the neighborhood. Inside the neighborhood, same subnet, the doorbell rings. Outside, it stays silent, not because no one is home, but because they're ignoring strangers. 4. In-depth explanation. Windows client machines, especially modern versions like Windows 10, 11, often block ICMP echo requests pings by default, especially if the request comes from a different subnet or network zone. Let's look at the logic. DHCP is working. The machine can browse the internet. You're not getting ping replies. Most likely culprit? Firewall settings that block ping ICMP from other subnets. The Windows Defender firewall has rules like allow ping from same subnet, block ping from different subnet. You could still RDP into the machine or browse from it, but ping fails unless the firewall rule is adjusted. Let's eliminate the incorrect answers. IP address expired. If that were true, the device wouldn't be online.
Yes.
Bad Ethernet port, it wouldn't connect to the internet at all.
Good.
Duplicate
Yeah, these would have the same outcome. Different culprit, same outcome.
IP would likely cause connectivity issues or erratic behavior, not just failure to reply to pings.
Interesting.
5. Real-world example
Yes.
or scenario. A help desk admin is trying to troubleshoot a workstation across town, different subnet. They ping the user's IP address and get no reply, but the user can still open websites and email. After some digging, they discover the Windows firewall is blocking pings from non-local IPs. Once they adjust the ICMP echo request rule to allow responses from any network, ping starts working. Let me know when you're ready for the next.
So, okay, in this real world example, they're saying that they're trying to ping a user's IP address, a workstation across town. So I'm thinking isolated IT. They're trying to ping this machine to see if they can get it because it can all be done remotely. They find out that the firewall is blocking pings from non-local IPs. So my question is, no, let's just add it on. And another thing. Does local mean physical location or local mean within the same network? For example, a company has 2 locations on different sides of town. Dang it. Town. Oh! My fat fingers is what did it. Okay. Different sides of town. Okay, let's clean it up. It matters, man. It sucks, but it matters. Okay. Also another thing, in your real world example, you said Windows firewall is blocking pings from non-local IPs. Does local mean physical location or local mean with the same network? For example, a company has 2 locations on 2 different sides. Let's see what it says to that. Because this has been a big deal for me. Like, I've always struggled with subnetting, and I know that it's a core component of network. And so I have to figure this out. I have to be able to do it. Don't worry, I got another. We're going on number 2, boys. Oh, God. Oh, that was not good after drinking that last one. Okay. I needed to cleanse my palate first. Let's see what we got.
You've asked exactly the right questions, and you're not alone. Subnets can...
Okay, let me just stop here. I feel like AI is unreasonably nice. I'm not saying that I don't appreciate it, but it does give me a false sense of accomplishment where I'm like, I'm asking all the right questions, am I? That's because I'm a smart cookie. Like, no, actually, I'm stupid. That's why I'm asking this question. Like, I don't know. Don't reinforce my stupidity by saying I'm asking the correct questions. These are really dumb questions that I don't know the answer to. That's why I'm asking you. But I do appreciate it because it could have patronized me and be like, you stupid idiot, let me tell you.
Can be confusing, but once you grasp why we use them and what local really means, it all clicks. Let's go deep using your preferred 5-part format to explain what subnets are,
yes,
why we use them, and why ICMP might block traffic from other subnets.
Okay.
Restated question. What exactly is subnetting? Why is it used if everything is still within the same company or private network? And when Windows Firewall blocks non-local pings, does that mean physical location or something else? Simplified answer. A subnet is a logical grouping of devices within a network. Even if they're physically nearby or on the same internet connection, devices in different subnets are treated as separate neighborhoods in the digital world. Windows Firewall uses local to mean same subnet, not same physical location. Analogy. Imagine...
Okay, so if it means the same local to be the same subnet, not physical location, then let's go back to and look at this example here. It says a help desk admin is trying to troubleshoot a workstation across town, different subnet. So it's associating across town with different subnet. But even though that's different, like it could be in the same building, it could be in the same room, and you could have two different subnets. That would be two different locals. They're just trying to insinuate, or they're trying to make it seem like, or not make it seem like, they're trying to solidify that a subnet is different by associating it with across town. Okay, they ping the user's IP address and get no reply, but they still can access the website and email. Okay, got it. Okay, after some digging, they discover the Windows firewall is blocking pings from non-local IPs. So meaning that's blocking pings that are outside of the subnet. I understand that better now. My question still stands. Why? Why would I want this? Why would I do this? Okay, where are we at?
In an apartment building with different mailboxes for each floor. Everyone shares the same building address, like a private network, but each floor has a different key and access rules like subnets. If someone from floor 1 wants to slip a note under your door on floor 2, the building rules might block that unless it's approved. In networking, floor equal to subnet, note equal to ICMP ping, building equal to entire private network.
Okay. Everyone shares the same building address. Each floor a different key and access rules. So within this analogy, if I wanted to send something to my neighbor who's on the same floor, no big deal. But if I wanted to send something to my neighbor who is upstairs, it's got to go through something, and it might get denied or it might get blocked. Whether it might not be approved, but it might be approved by me, might not be accepted by the person above. Okay, so the floor is a subnet. The ICB, which is the ping, is the node, the message I'm trying to give. And the building is the entire private network. So that's the entire apartment. Okay, Windows Firewall equals the security desk that checks who is allowed to send you notes. Okay, so it's not necessarily who you are allowed to send notes to. It's who you are allowing to accept notes from. Okay, let's keep going.
Windows Firewall equal to security desk that checks who's allowed to send you notes. So even if the computers are in the same building, the subnet rules matter more than the physical location. In-depth explanation. What is a subnet? A subnet, short for subnetwork, is a way to organize devices into manageable groups, control traffic more efficiently, reduce broadcast traffic, and improve security and performance. Every IP address has a network portion and a host portion. The subnet mask, like 255.255.255.0, tells devices which part is which. Example: IP 192.168.1.15. Subnet mask 255.200 and 55.200 and 55.0. Only devices with 192.168.1.x are considered local. If another device has 192.168.2.10, it's in a different subnet. Even if both are on the same physical network.
Okay, it's in a different subnet. And this right here has to do with how subnetting is created. Like, how do I create this subnet? And it has to do with 32 or 64 bits and these last two numbers, or this last number. And that's how it turns into what it is. It's this really strange pattern that doesn't quite work the way you think it works, but the way it works makes total sense. I just don't quite remember how that is. Maybe I'll ask in a second. How do you make a subnet? I'll use this as my example. How do I subnet this this IP address? Okay, let's keep going.
The computer says, "This guy isn't on my floor. I need to go through a router or firewall to talk to him. Why does ICMP get blocked by?"
So basically, I guess it's another way of security as well, because if I'm on one subnet, I can freely communicate with everyone on that subnet and know that everything that's on that subnet is perfectly safe. And if I want to talk to somebody else outside of that subnet, I'm now going outside the house. I'm now going somewhere else. So I'm exposed to all of the everything. I'm exposed to everything. People could, I guess, could intercept the message maybe, and maybe the new subnet, maybe I could be redirected or something. I don't know. Let's keep going.
By default, ICMP ping is often used in scanning attacks. Windows Firewall's default security rules say, "Let's only respond to pings from devices on the same subnet, unless the admin allows otherwise." This reduces risk.
Yes.
A machine won't respond to unknown outsiders just because they're on the same company network. Even inside a company, subnets are used to. Separate departments, HR, finance, engineering. Control traffic between buildings or locations. Prevent one compromised system from pinging everything else.
Okay, that last one makes sense. Preventing one compromised system. This is also a means to stop or mitigate compromised things. So if someone in HR's gets phished and their system's compromised, chances are only HR is going to get compromised. Now, they might have links to other things that might compromise people who are in finance or engineering, but those are going to compromise individual people, not the entire department, which is going to help isolate and be able to narrow down the issues. That makes total sense. Okay. Also controls traffic between buildings and locations. Okay. I wonder if this would go along with probably, I don't know. If I'm in HR and I send an email to finance, but we're having subnetting issues, am I still going to be able to send that email or not? My initial thought is no, because I'm having subnetting issues. I'm not going to be able to do it. My second thought is yes, because it's email and it's using the WAN. It's using a different tunnel. I could be wrong. Let's keep going.
Real world example. You're a sysadmin for a company with HQ in Dallas, subnet 192.168.10.024. Branch office in Austin, subnet 192.168.20.024. Both locations use VPN to connect over the internet.
Okay.
You try to ping a Windows PC in Austin from your office in Dallas. Ping fails, even though you know the IP and the device is online. Why? Because the Austin PC sees the ping as coming from outside its local subnet, and the Windows firewall silently blocks it, even though you're both inside the company. If you allow ICMP for any IP in Windows Defender Firewall, the ping works fine. Summary key points. Subnet equal to logical separation, not physical. Subnets allow better control, security, and performance. Summary key points. Subnet equal to logical separation, not physical. Subnets allow better control, security, and performance. Local means same subnet, not same room or building. ICMP is blocked by default across subnets to reduce risk. Windows Firewall isn't being rude, it's just playing it safe. Would you like a visual diagram of subnet separation, or are you ready for the next question in section 5.3?
Yeah, yes. Yes, make me a visual diagram. Let's see what it makes. I bet it makes it out of code. Not making a diagram. Soul ethereal. Oh, internal. I thought it said ethereal. What? It did not make it. How did you know it wasn't going to do that? There it goes. Oh, it's going to make an image. I thought it was going to write it like in code. Sometimes it asks me to do it and it'll create it using a code or like the, not code, but like a text thing where, you know what I mean? Let's see what it makes. Very interested. Also, while we wait for it, so my follow-up question. So if HR is on a subnet and sales is on another subnet, then I've tried this before with certain diagrams, but yet it takes a good while. Yeah, I've noticed it's way better at making images, like pictures and stuff. Like, I mean, my thumbnail for this YouTube video, because I'm streaming on YouTube and Twitch, the thumbnail came from Chatbot GPT. So that didn't take very long, but I have noticed that diagrams take a long time. I've only had it make like a few though. Does that mean where I cannot ping from sales? Does that mean that HR cannot send emails to sales or connect with them at all? Or does that mean that HR cannot connect to the same internal apps that sales can? Oh, also, oh wow, you cannot see the chat to save its life. Let's I don't know where to put this thing. I guess I can put it like right there. Yeah. Anyway. Oh look, it made the diagram. Sweet. So subnet is 192.168.10.24. 192.168.20. So then we have this. There's the router. Assuming that it created it correctly. 1.10, 1.20, 1.10, 1.20. So these are the subnets. Okay. Let's have a follow-up question here. Interesting. I mean, that makes sense to me. Still doesn't answer the question of like how to do subnets. I know I've asked a bajillion times. I know I've gone through it a bajillion times, but I still having a hard time understanding it. It's like kind of like how I kind of forgot how they create IP addresses. Like I remember the math, I remember doing it, but I have a hard time. I need to go back to Sonny's classroom. Sonny's a YouTuber that I watch often. All right, let's see what it says.
Excellent follow-up. Let's clarify this fully using your preferred 5-part breakdown so there's no confusion. Restated question. If HR and sales are on different subnets and there are subnetting issues like not being able to ping from HR to sales, does that mean HR can't send emails to sales, access internal apps used by sales, or is it something else entirely? Simplified answer, no. Subnetting issues don't block emails or apps by default. They only block communication if routing between subnets is misconfigured. You can still send emails and access shared services if the network is properly set up, even across subnets. Analogy. Think of HR and sales as two separate departments in a large building, each on its own floor. Subnet emails are like inter-office mail. They go through a mailroom email server that connects both floors. Internal apps are like a shared cafeteria. As long as the elevator router works, everyone can access it. Ping ICMP is like knocking directly on a door. If the security policy says don't answer knocks from other floors, the knock goes ignored. So if the elevator router or firewall is misconfigured, HR can't visit.
Okay, I think the knowledge that I'm missing is I guess I don't fully understand the power of what a ping means. I know that if I have one machine here and another machine here, and I want to make sure that they can talk to each other, I can have machine A ping machine B. And it'll be like, yeah, we are connected. We can talk to each other. And I know on the surface level that means like a lot, and that's really, really powerful. But on this on a more in-depth level, it's like, what exactly does that mean? Like, what, now that I know that these two machines can talk to each other, what does that mean? What can I do with that? If I could already still send emails, if both machines already had contact or access to internal application and things like that, then what was the purpose of a ping? Why did I need to do that? Is it maybe bad actors coming in and trying to ping? And okay, so then why would a bad actor want to try to ping my machine? You know, what does that mean? Does that mean that they can get in? Maybe.
Emails are like inter-office mail. They go through a mailroom email server that connects both floors.
Oh, dang it.
Analogy. Think of HR and sales as two separate departments in a large building, each on its own floor. Subnet emails are like inter-office mail. They go through a mailroom email server that connects both floors.
Yes.
Internal apps are like a shared cafeteria. As long as the elevator router works, everyone can access it. Ping ICMP is like knocking directly on a door. If the security policy says don't answer knocks from other floors, the knock goes ignored.
Okay.
So if the elevator router or firewall is misconfigured, HR can't visit sales, but they can still exchange mail and use shared services if those systems are on accessible floors.
Interesting. Okay, let's see what the more in-depth answer is.
In-depth explanation. 1. What subnet separation means. When HR is on 192.168.10.0, 24 and sales is on 192.168.20.0 24, they're in different subnets. To talk, they need a router or layer 3 switch to route traffic between the subnets. 2. What can't ping really means. If HR can't ping sales, it's usually an ICMP block by a firewall, Windows, or network, a missing or broken route, a VLAN misconfiguration.
Cause math. Okay, what does the acronym of math mean again? These acronyms are killing me, dog. I'm not even gonna lie. Okay, yes, subnet masking is tedious because, oh, no, you just are emphasizing the word math. Yes, you are correct. It is tedious because of math, but it's a simple formula. I don't know if we're going to go into that because I would want to get through the rest of this because, as you can tell, there's still a lot to do over here. Where'd my mouse go? There it is. Yeah, because of this. But anyway, here we go.
Ping is just a testing tool. It's not required for services to work. It only tells you, can I directly reach this other machine? 3. Email and apps usually work. Email and internal web apps typically live on servers, not on the personal devices in HR or sales. As long as the servers are on accessible networks and the routes exist between subnets, then yes, HR can. Send receive emails to sales. Use internal apps also used by sales. Access shared drives, printers, etc., even if ping doesn't work.
Interesting. Okay, let's look at the real world scenario. So imagine HR is on the VLAN 10. It's called 10 because there's 10 there. VLAN 20, they use 20 because 20 is there. A lot of times you rename the VLAN the same as the subnet in order to make it make sense, but it's not always. Side note, whenever you're naming VLANs and things like that, you don't want to use like Scooby-Doo or like, I don't know, like you don't want to use like stupid names. a router or layer 3 switch connects them. An email server is on VLAN 100. So email is just on its completely different VLAN. Man, dude, it's like this. I know it's called the web, but like Jesus, it's like this huge interconnected web. If the router has proper routes and firewall rules, allow TCP, block ICP or ICMP, then emails can flow, internals can work both ways, are for both, but pinging from HR to sales fails unless ICMP is explicitly allowed across VLANs. And we don't want to do that, because if we allow that, then the chances are bad actors are going to ping. Now, I don't necessarily know what that means if you can ping. Like, for me, an outsider, if I'm able to ping HR, what benefit is that to me? Pings fail total. Let's ask that real quick. Okay, and this will be the last one, then we'll get back to the questions. Okay, so if me, an outsider, not a part of the what am I looking for? Okay, so if me, an outsider, not a part of the company, can ping an HR device, what does that mean? What benefit? Benefit? That is not how you spell benefit. Not even close. Okay. What benefit is that to me? What can I do with that? I swear to God, if it comes up with some type of like ethical bullcrap or something, I'll be upset.
Excellent and very real-world question. Let's fully break it down using your 5-part method.
You see what I mean by like the over niceness? Like, it's making me feel like I'm a network administrator already, and I haven't even taken the damn test.
Restated question. If you're an outsider, unauthorized person, and you can ping an HR device, what does that mean? What benefit does that give you as the outsider, and what could you potentially do with it? Simplified answer. If you can ping a device, it means the device is reachable, not blocked by a firewall. The IP address is active, and you now know there's a live system on the other end. While ping doesn't let you hack anything directly, it's the first step in identifying vulnerable targets on a network. Analogy.
Okay.
Imagine a neighborhood where you're knocking on every door. If the door knocks are ignored ICMP blocked, you assume no one's home. If someone knocks back ping reply, now you know someone lives there. You don't have the keys to get in, but now you know which doors are worth picking.
Okay, this makes sense, because in PewDiePie's video where he talked about how he made his own server, which I'm currently doing as well, he was talking about how he was getting pinged by a bunch of bots. And he was like, I don't really like that. And I was like, yeah, that kind of sounds scary, but I didn't fully understand why. It just sounded like a bad idea. This makes sense, because it's telling people like, hey, I'm home and the door's unlocked.
In-depth explanation. 1. What ping reveals. A ping reply tells you the device is up and running. The IP address is valid and reachable. There are no firewalls or filters blocking ICMP. This is useful for an outsider doing reconnaissance, mapping the network, planning an attack. 2. What happens next? If an attacker can ping a device, they know it's active. They might run a port scan next using tools like Nmap. If ports are open like HTTP, RDP, SMB, they could try to exploit vulnerabilities, attempt brute force logins, launch denial of service attacks. So while ping doesn't let them hack in, it starts the process of enumeration, which is critical in cyber attacks. 3. Why it matters. Good security practices often involve blocking ICMP from untrusted sources, so outsiders can't even confirm if a device exists. Real-world example. An attacker from outside the company runs a basic Nmap ping sweep like bash copy edit nmap SN 192.106. If they get ping replies from HR devices, they know the network exists. They see which devices are alive. They might follow up with Nmap SV to find services versions.
Okay. I get it. So basically, if I'm able to ping something, it's the first step in knowing that something, kind of like how Like if you go to like a public area, we got an Amber Alert. Okay. Anyway, kind of like how there are robbers who will go like around like a parking garage or something, and they'll just pull on doors. And if a door is open, then they're gonna rob it. But if it's not, they're gonna move on because they're looking for easy things. Or, you know, like there's some other things that people do. I don't know if that's necessarily a good analogy. All right. So now let's go back to the actual question here. It's been a while.
A network administrator is testing a remote server's network configuration and decides to ping the Internet Protocol IP address of a familiar Office Windows workstation. No replies are received, but the admin confirms DHCP settings are enabled on the workstation and can successfully browse the Internet. What is the most likely reason why the client workstation did not respond to a ping request?
Okay. What day is it? Wednesday. Okay. So this makes total sense. The IP address from another subnet is being used. That's why. Okay, that makes so much sense now. Let's move on. Oh my gosh. I stayed there so long that it timed out. Well, now you guys are all going to see my stats. Okay. Next. Let's see what's going on with this bad boy. I hate when it takes forever for it to read.
In a newly set up branch office, a network administrator configures the network with the subnet 172.116.0.016. All devices are supposed to communicate within this subnet. However, the administrator notices that host X, with the following configuration, cannot access the shared resources located on a server within the same subnet.
Okay, so that means that the subnet mask is too restrictive. I know that this 16 determines how many IP addresses are going to be limited to that subnet. What is the primary reason for host X inability to access the shared resources? The correct answer is that the subnet mask is too restrictive. The subnet mask of 255.255.255.0/24 is too restrictive for the intended subnet of 172.16/16. This incorrect subnet mask limits host X to a 172.16.25.24 subnet, preventing it from accessing resources outside this range within the larger range /16 network. I understood that enough to understand that the subnet mask is too restrictive. But this also goes back to understanding exactly what a subnet mask... Well, I know what a subnet mask is now, but being able to set it. I know that you get this... You take this number to get these. Okay, we're gonna continue on. I'm just gonna accept that in my soul, in my heart of hearts. I'm just gonna accept it that this is the right answer, and that in the future I will understand.
Users are reporting that they are unable to access the company's shared drives within the corporate wireless. However, if they are hardwired, they can access the shared drives. What is the most likely reason that they are having issues accessing the shared drives?
Okay. Now, I thought it might have been attenuation, even though I knew that was probably not right. The only reason I did that was because it said corporate wireless, and attenuation is degradation of a signal. So it made me think like maybe that's why, but that means that they wouldn't be able to access anything, not just this one particular shared drive. So DNS issue, let's see what it has to say about DNS issue. This is another core concept that I struggle with.
Issues with DNS may prevent the access of company shared drives, which are typically accessible through fully qualified domain names.
Because domain names are more than just URLs. Domain names can be like through a company. No one's watching song. Okay, let's get rid of this. Boom, that's gone. Done. 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 Okay. See what we got here.
Perfect. Let's break this question down thoroughly using your 5-part method. Restated question. Why would users on corporate Wi-Fi be unable to access shared drives, but those on wired connections can access them just fine? Correct answer. DNS issues. 1. Simplified answer. The W-Wi-Fi network likely has misconfigured DNS settings, so devices can't resolve the shared drive name to an IP address, even though they're connected to the network. 2. Analogy. Imagine two groups of people trying to call John. The W-Wi-Fi network likely has misconfigured DNS settings, so devices can't resolve the shared drive name to an IP address, even though they're connected to the network. 2. Analogy.
Okay, I can tell the reason I don't understand this is that I'm missing core fundamental knowledge of what DNS actually is.
Imagine two groups of people trying to call John using a phone book. The wired users have a full phone book. They find John's number and call. The wireless users have a phone book with missing pages. They can't find John's number, even though John is home. In this case, the shared drive is John, and the DNS server is the phone book. 3. In-depth explanation. Most shared drives on corporate networks are accessed via hostnames or UNC paths, like cpppp edit file server 1 to public. This requires DNS to resolve file server 1 into its correct IP address. If the wired network uses an internal DNS server, for example, 192.168.1.5, but the W-Wi-Fi network is using a public DNS server, for example, 8.8.8.8.
That's Google, by the way.
Then devices on W-Wi-Fi won't know where file server 1 is, even though it's right there on the network. The drives are still accessible if you manually enter the IP, which proves it's a name resolution issue, DNS. Let's eliminate the wrong answers. Site survey, that's a planning tool, not a fix. Attenuation. Signal loss doesn't usually cause only shared drive failures. Baseline, that's a monitoring concept, not directly relevant here. 4. Real-world example or scenario. Let's say your company's file server.
Site survey, that is a planning tool, not a fix. Signal loss doesn't usually cause only shared drive failures. I already said that. That's a monitoring concept, not directly relevant here. So that's what I thought.
Is hostname, corp file 01. IP.
Okay, and add to our question.
IP address 192.168.210.
I don't need to read me all these numbers. Okay, let's say your company file server is hostname this. We got 0.20, 0.10, 0.20, 0.1. That's our default gateway, right? Your wired users are IP 0.20, .x. DNS is 0.20, 0.1. If your Wi-Fi users get 0.50, .x, DNS is 88888. So when a Wi-Fi user tries corporate, the DNS server says, I don't know who that is. So how's that different from a default gateway? Or is... So is the DNS the head of all IPs, meaning that all default gateways are trying to lead back to the DNS? I've got a lot of questions here. Some of them I don't think make sense, but that's okay. I want the answers. Okay. So from a Wi-Fi user tries to use this, Mm. I don't fully understand. Send a follow-up. Let's see while we wait for that. Let's see what the other answers.
A performance baseline establishes the resource utilization metrics at a point in time, such as when the system was first installed. This provides a comparison to measure system responsiveness later. A site survey is performed first by examining the blueprints or
That makes
floor
sense.
plan of the premises to understand the layout and identify features that might produce radio frequency interference (RFI). Attenuation is the loss of signal strength that occurs as the signal travels through the media.
We learned that last time. Fantastic question.
Fantastic question.
You're
You're now
welcome.
digging into the core mechanics of how networks find things, which is crucial for Network Plus. Let's go step by step using your 5-part breakdown. Restated question. What is DNS and how does it differ from website domain names, host names, the default gateway? And how do all these things work together?
Yes, tell me.
Simplified answer. DNS domain name system translates names like google.com or fileserver1 into IP addresses, so devices know where to connect.
Okay, see, I knew that. I forgot that, but I knew that. So DNS literally just translates names. Okay, let's just keep
A
going.
host name is a name given to a device on a network like laptop01. A domain name is usually used for internet resources like openai.com. The default gateway is the IP address your device uses to send traffic outside its local network. It's like the front door. DNS and the gateway are not the same, but they both help your traffic find where it needs to go. Analogy. Imagine a large company building. Every employee device has a name badge. That's the host name. You want to call accounting. You ask reception DNS to look up their room number IP address. If you're on the same floor subnet, you walk there yourself. If they're on a different floor or building, you go through the elevator lobby default gateway. So, DNS equal to receptionist, phone book. Host name equal to name badge. Domain equal to department or company name, for example, sales.openai.com. Default gateway equal to elevator lobby that gets you to other networks. In-depth explanation. What is DNS? DNS stands for Domain Name System. It's a directory service that translates human-friendly names into IP addresses. When you type, copy edit to www.google.com. Your computer asks the DNS server for the IP address of www.google.com. The DNS server replies 142.200 and 50.100 and 90.68. Your browser then sends traffic to that IP. Hostname versus domain name. Hostname, the name of a specific device on a network, for example printer 01, HR server, laptop 01. Domain name, the name of a network or internet resource, often ending in com, net, etc. Example, sales.mycompany.com equal to hostname.subdomain.domain. So, a fully qualified domain name, FQDN, includes both PGSQL copy edit printer 01.office.local, hostname plus domain. DNS in a local network. In corporate networks, you might access a shared drive via tune file server 1.docs. Your DNS server internal resolves file server 1 to 192.168.120. But public DNS like 8.8.8.8 has no clue about your local server. How is DNS different from the default gateway? DNS translates names, IP addresses. Default gateway moves your packets to other networks, for example, from 192.168.1.0, 24 to 10.0.0.08. They work together, but serve different jobs. DNS says, where is google.com? 142.250.190.68. Gateway says, you're not on that network. Let me send it out to the internet. Real-world example. Let's say your laptop is trying to visit PGSQL copy edit to www.corp-internal-app.local. Here's what happens. DNS lookup. Your DNS server says, that's 192.168.100.22. Your device checks if that IP is on the same subnet. If yes, it connects directly. If no, it sends the packet to the default gateway, which routes it to the right.
Okay. Let's see if it'll make this diagram. I also have questions because, like, I know that, like, my laptop still has the DNS Like when you go into its network settings, it still has its DNS of my old school that I used to work for. Like it thinks that it's DNS. I don't know how that works. So interesting. Let's go back to the question at hand here while we let that generate. We learned earlier that's going to take a while.
Users are reporting that they are unable to access the company's shared drives within the corporate wireless. However, if they are hardwired, they can access the shared drives. What is the most likely reason that they are having issues accessing the shared drives?
So they're having DNS issues. But the DNS issues are only happening on the wireless. It's not happening on the hardwired. I understand it enough to understand that DNS issues is the correct answer, but I don't understand enough to understand why DNS issues is the correct answer. Like, I understand that it's not site survey, attenuation, or baseline. What is site survey again? Site survey is a performance first by example of the blueprints or floor plan of the premise to understand the layout and identify features that might produce radio frequency interference. Okay. So it's literally the survey of whatever, like, you're about to lay the network stuff in it. Okay. Let's move forward. We'll come back to it. We still have like more to go through.
What happens when a topology change notification TCN is received in a network using STP?
STP, I didn't know, but I learned it a second ago. The answer is ports may change their status from forwarding to blocked or vice versa. So what happens to a topology change notification? We'll come back to it. Let's look at here. Okay. So user request file server 1 example.com. DNS server responds because now it's changing this name into this IP address. Then it goes to the gateway. Send packet to this, which goes over here, file server 1, which is this IP address. And this is the server. And then it goes back to the user. Okay. Oh, does a school or private or company need its own DNS server to translate all of its domain names to IP addresses because it's dealing with a whole bunch of private IP addresses? Because everything has an IP address? I think that's the answer.
Great question. Let's break this down using your preferred 5-part format so you can truly understand how. DNS works inside a large organization, like a company or school, that uses names like normalhighschool.local or normalhighschool.com. 1. Restated question. How does DNS work in a large company or school that uses a custom domain like normalhighschool.local or normalhighschool.com, and why does this show up in network settings? 2. Simplified answer.
I love it's like right here it says my stupid answer or my stupid question, and then it restates it and makes it a good question. And then now it's going to give me an answer. Okay.
Large organizations run their own DNS servers to manage internal names for devices and services.
Yes.
These names, like normalhighschool.local, are not resolved by public DNS, but by the organization's internal
Okay,
DNS.
so it's my
3.
conclusion I just came up with.
Analogy. Think of DNS like a company phone book. The public phone book, Google's DNS, etc., lists well-known numbers like www.microsoft.com. But inside the company, they keep a private internal phone book with extensions for employees and internal departments. So when a device in the school tries to find fileserver.normalhighschool.local, it uses the school's DNS server, not the public internet.
So then I could name my printer in my closet and have my DNS, if I had a DNS server, and have my DNS server, like, it all be connected to that. And that's why it's all has normal, like, it would be like paradiddlepete's.local, and then it would be printer.paradiddlepete.local, and then that would have its IP address. Okay, it's starting to make sense.
4. In-depth explanation. What is normalhighschool.local or .com in this context? These are internal DNS domains used to identify and organize network devices and services. Local is often used for internal-only networks. .com, even when used internally, for example, corp.normalhighschool.com, is mapped inside the organization, not necessarily on the internet. For example, laptop23.normalhighschool.local, studentportal.normalhighschool.com, printer1.office.normalhighschool.local. These names are automatically assigned or configured by DHCP or network policies when a device joins the school network. Why do these show up in network settings? When your computer joins a school network,
So it also falls back down on the core principles, like fundamental knowledge of the difference between the intranet, internet, and extranet. These are all different things, but they're like a Russian little Russian doll where you open it up and there's like more, like smaller ones inside of it. It's basically like that. So I could have I could have a network, a home network, and it could be paradiddlepete.com or paradiddlepete.local, and then it would be like petespc.paradiddlepete.local, something like that. And then if I had multiple things, that were going on, then I could have my DNS server translate it so that way it could all talk to everything. Now, it doesn't really make sense for me to do that inside my house, although I'm probably going to because I'm an idiot. It doesn't really make sense for me to do that inside my house because I don't have that many devices. And it's all going to be hardwired anyway. But still, well, it would still help. And probably not. It's probably overkill. Anyway.
It's given a DNS suffix like...
Okay. So when your computer joins a school's network, it's given a DNS suffix like normalhighschool.local. That's exactly what happened to my laptop. This suffix is used to resolve short names like library printer to full names like libraryprinter.local. So then... Oh, I had a hard time connecting to the Wi-Fi when I first got to my first school. I had to give it to the IT guys. They set it up and they turned it into one of their devices. Well, kind of. They set it up and they gave it a suffix, so that way the DNS server would be able to process it. Interesting. Okay. A local DNS server like Windows Server with DNS roles. Possible activity. Okay. Real world example. You're a student using a school issued laptop on the Wi-Fi network. You type / gradebook. Here's what happens. Your company, your computer, the DNS suffix gradebook sends a DNS request to the school's internal DNS server. The DNS server says, yes, gradebook, blah, blah, blah. Your browser opens the gradebook website app hosted on the internal server. But only they can access it because they're on the network. Okay. I still think that there's a few holes, but I'm definitely understanding it so much better. Okay, so then let's go back to this. This was the issue. So I went way overkill, and I understand DNS way better now. However, I still don't understand why the wire, like, well, I do understand. It's because the issue is DNS. If for some reason the wireless is resolving the DNS differently than the hardwired. Now, why that is, I don't know. That's going to have to require something else, but let's keep going. Now, let's talk about this thing, okay? Oh my gosh, dude, I cannot. That Q, whenever I'm trying to type Q, like my left hand like spazzes.
When a TCN is received, it indicates that a device has been added or removed from the network. STP may then adjust the network topology by changing the status of ports from forwarding to blocked or vice versa to maintain a loop-free network.
Interesting. Okay.
Great. Let's break this STP-related question down using your 5-part explanation format. 1. Restate the question. What happens when a topology change notification, TCN, is received in a network that uses spanning tree protocol, STP? 2. Simplified answer. Ports may change their...
So topology change notification, TCN, got it. Spanning tree protocol, STP, got it. Keep going.
status from forwarding to blocked or vice versa. 3. Analogy. Imagine your city has a traffic control center like the route bridge that manages road closures and detours. Suddenly, a bridge collapses or a new one opens, topology change. The city sends out an alert TCN, and the traffic control center updates which roads should be open or closed to keep cars flowing smoothly. Some roads are open forwarding, others blocked to prevent traffic jams loops. 4. In-depth explanation. STP, spanning tree protocol, is used to prevent loops in Ethernet networks by ensuring there's only one active path between any two network devices. It does this by placing some switch ports into a forwarding state and others into a blocking state. A topology change notification, TCN, is triggered when a link fails or comes back online, a switch or port goes up/down, a device is added or...
Okay, so STP, spanning tree protocol, that's essentially like a traffic, like a traffic guard, or, you know, like someone, he's basically just like, hey, you stop, let these go. Hey, you stop, let these go. Like, he's stopping those things. Now, the only difference is that he's straight up stopping those cars completely and telling them to turn around, or to just, they'll be there and then they die because of time, end of life.
or removed. Once a TCN is received, it's sent. A topology change notification, TCN, is triggered when a link fails or comes back online, a switch or port goes up/down, a device is added or removed.
Okay.
Once a TCN is received, it's sent upstream toward the route bridge. The route bridge then informs all switches to age out their MAC address tables faster. Ports may recalculate their STP roles route, designated, or blocked. Some ports may change states. A blocked port might start forwarding or vice versa. This helps the network quickly adjust to the new topology without creating loops or black holes. 5. Real-world example. You have 3 switches, SW1 route bridge, SW2, SW3. A cable between SW2 and SW3 goes down. That's a topology change. SW2 detects it and sends a TCN upstream to SW1. SW1 then alerts the rest of the network. Something changed. Reset your MAC tables sooner and prepare to recalculate STP roles. The result?
Wow.
Some ports might switch to forwarding to keep connectivity. Others might block to prevent loops. So the network adjusts and restores a stable tree topology. Let me know if you'd like a diagram of STP and TCN behavior.
Wow.
Or if you're ready for the next question.
That's so crazy. That's so much that goes on. That literally like blows my mind that all of this just happens. Just happens. And you have no idea. You have no idea. Now, granted, most people don't have a switch, or let alone 3. I mean, I only have one. It's a little 8-port switch. It's about to get upgraded so that way I can get rid of Wi-Fi. However, like, I'm not the norm. That's crazy. So what happens when so this is a very basic question. Scenario troubleshooting, common issues with network service. What happens when a TCN, a topology change notification, which is like something like this, like what I just talked about, is received in a network using STP? Ports may change their status from forwarding to blocked or vice versa, and they do this to stop looping. So all ports are set to blocking? No. The root bridge is re-elected? No. I think that only happens if the root bridge goes down. If the root bridge goes down, then I think it gets re-elected. Okay. The network topology remains unchanged. It cannot remain unchanged. Otherwise, it's going to get bogged down and there's going to be loops that happen. It's not going to be good. Let's see here. Root change re-elected. Let's see where we can find notification. Loop free. Okay, thus topology is changed in response to such notification. The topology change notification does not trigger. Here it is. Let's look at this.
Topology change notification does not trigger a re-election of the root bridge. The root bridge election is a separate process that occurs based on bridge IDs, not on topology changes.
Okay, well, that didn't.
Learning 5.3 given us.
That did not reaffirm my assumption of when this happens, but it does affirm that this is the correct answer and my understanding of it. Let's move on to the next one. This is another one that I should have didn't know, but that was also before I understood what spanning tree protocol is.
You are configuring a new network segment that includes 3 switches, switch A, switch B, and switch C. Switch A is connected to switch B is connected to switch C, and switch C is connected back to switch A, forming a triangle. To prevent loops, you decide to implement the spanning tree protocol STP.
Okay.
After enabling STP, you notice that one of the links between the switches is not forwarding traffic. Which of the following links is most likely to be in a blocking state due to STP?
Okay, so after establishing STP, you noticed that the links between the switches are not forwarding traffic. Which of the following is most likely to be in a blocked state to STP? I don't know. Any of the links could be in a blocked state depending on the bridge ID. Okay, well that explains why I wasn't, because in my brain I was trying not to look at it. I was trying to like figure it out on my own. And I was like, okay, well which switch would it be, A, B, or C? But they're all connected together through one line. It's not like a tree where our web where A is connected to B and C, C is connected to B and A, and then B is connected to A and B, where they're all connected to each other. Since they're connected in basically a circle, triangle, and after this protocol is turned on, any of them could be in a blocked or forwarding state, because there is no there's no leader, there's no hierarchy yet. Okay, let's see if that's correct. Let's see what we got here.
Any of the links could be in a blocking state depending on the bridge IDs is the correct answer. In SDP, the decision to place a port in a blocking state depends on the bridge IDs and the path costs to the root bridge. Since the bridge ID is a combination of a priority value and the MAC address, and without specific information about these values or the path costs, any of the links could potentially be in a blocking state. The specific link that ends up being blocked is determined by the STP algorithm based on the bridge ID and path cost calculations to ensure a loop-free topology.
Okay. And it says, without information about the bridge IDs and the path cost, it's not possible to identify, say, which specific link would be in a blocked state. STP calculates could result in any link being blocked to prevent loops. Okay. Makes sense.
What might be a symptom of a malicious attack on a DHCP server?
And I said address pool exhaustion, because if it's being attacked, it's going to exhaust all of the IP addresses that it's going to give out. So frequently IP address changes, it's not going to ask for changes. That's not what it's going to do. Okay. If anything, it's going to give out bad IPs or incorrect IPs. Decreased number of DHCP requests, most likely not. Increased network speed, definitely not. That is a hard no. Address pool exhaustion. Okay, let's see what it says.
Address pool exhaustion can be a symptom of a malicious attack, such as a DHCP flood where numerous fake DHCP requests are sent to the server to deplete its pool of available IP addresses, preventing legitimate clients from obtaining an IP address.
Good. Are more likely due to a shortage lease time. Okay, that makes sense because when you're changing anything with the DHCP server or something like that, you always cut the lease time down to as quick as possible to prevent duplicate IPs from being assigned. A decrease in number of DHCP requests would not indicate an attack. The attack would likely increase the number of requests. Yes. Because it wants to exhaust the pool. Because if it exhausts the pool, then that means it's going to cut devices out.
A user installs a financial software package that requires cloud access. For some reason, the application fails to connect to the cloud server. What is the most likely cause of this issue?
Incorrect host-based firewall settings. Yeah, this is one that I figured was correct as well. So user installs a software that requires cloud access. It does not imply that they cannot get access to the website, just that they can't get access to the cloud server. So that means that they're online. If they're online, it's not the incorrect time. That would be really stupid of a cloud service to have. You could only access it during certain times. Okay. Introspective services, not sure what that is. Duplicate IP address, no. Okay, let's see what it has to say about this. And I want to see the unresponsive service time. Okay, we're going to see
a host-based firewall is implemented as a software application running on a host. Often rules need to be manually added to a firewall allow for applications to communicate properly.
It needs a tunnel. It needs not necessarily like a VPN tunnel, but it needs a tunnel. It needs a way to get to it.
An unresponsive service on a system can be caused by many factors. These services may include important network functions, such as Dynamic Host Configuration Protocol, DHCP.
Interesting. Okay. All right. Keep going. A puppy.
Recently booted computer systems at a large company are not able to access any network resources. IT investigates and finds the systems configured with automatic private IP addressing APIPA addresses. Which of the following is most likely causing the issue?
Exhaust the DHCP scope. Because the way a DHCP scope works, it is the scope of how many IP addresses are going to be assigned to this thing. Which I now believe that it's how many of these IP addresses are going to be assigned to this subnet, this group. Okay, and that's how you can kind of determine how many IP addresses are there. And it's very structured. It's not like you can just have like 7 IP addresses assigned to a certain subnet. It's like you're going to have, I think it's like 8, 16, 64, like it's in groupings like that, if I remember correctly. So a puppy, that means that if your computer is not assigned an IP address by the DHCP server, or it's not assigned, does not have internet capabilities, or it's not attached at all, what happens is that your computer will automatically assign its own IP address to itself, and it's usually 169. Is 169 dot something dot something dot something, and that 169, that first digit, usually indicates, not usually, always, it indicates that you are on a private network of one, basically. You cannot connect to literally anybody. The reason it does that is so that way you could still connect your computer to another computer and use that internet, IP address, and they would be able to talk to each other. Now they're only going to be able to talk to those two devices. Are only going to be able to talk to those devices. This is how Xbox LAN parties used to work. There's other ways of like how that used to work in terms of like cabling and stuff like that, but that's how that works in terms of IP addresses. So this is making a lot of sense. Okay.
If systems are failing to obtain an Internet Protocol IP configuration, a Dynamic Host Configuration Protocol DHCP scope may be exhausted, which results in the assignment of APIPA addresses.
APIPA! Yeah. I don't remember what APIPA stands for. Oh, Automatic Private IP Address. A pipa. Yeah. Yeah. Look. You don't want to get a pipa. If you get a pipa, you're gonna be losing packets. You don't want to be losing packets. If you're losing packets, you're gonna have a bad time. Okay.
Windows workstations at a small company are not able to log on to a Windows server. Which of the following is the likely cause?
Okay. So Windows workstations in a small company are not able to log into a Windows server. Which of the following is most likely? So that would mean incorrect system time? No. Block UDP ports? That doesn't make a lot of sense. It's probably using TCP. So I don't know. That doesn't make any sense to me. Okay. An untrusted SSL secure socket layer certificate. So they're not able to log onto the Windows server. Could be incorrect ACL access control list. I think it's this one. And I'm wrong.
After a sysadmin fixed the configurations of one of the switches, the number of packet collisions dropped to near zero. What setting was most likely contributing to the packet collisions?
Ooh. I'm going to say speed or duplex. Yes.
A computer system sporadically connects to network services. Which of the following is most likely causing this issue?
A computer system sporadically connects to network services. Wait. What?
Answer: incorrect gateway. A computer system sporadically connects to network services. Which of the following is most likely causing this issue?
Oh, okay. I took it as a different meaning. Like it was just randomly connecting to network services that were not requested, but it means that they're being requested and sometimes they're being denied and sometimes that they're being allowed. So, interesting. So, what would be the biggest culprit of this? If I'm at work and I cannot connect to network settings, is it going to be an incorrect gateway? I feel like that's not the answer. A rogue DHCP server? I feel like if that was the case, I wouldn't be able to connect at all. Expired IP? If that was the case, I would not be able to connect at all. Duplicate IP? I'm going to say it's one of these two. I don't know how it could be incorrect gateway, but that could just be my ignorance of not knowing something. Okay.
A network engineer is tasked with resolving why certain printers are inaccessible by users next to those printers. The engineer realizes that the printer's network port on the switch is not configured to the proper network. The engineer sets the network configuration tag to 30% for those ports, resolving the issue. What was most likely the cause of the issue?
The engineer sets the network configuration tag to 30 for those ports. I don't know what a configuration tag is. I think this was, from everything that we just read, it sounds like it was a DNS server issue or DNS issue. But based off of the answer of what fixed the problem is that the engineer set the network configuration tag to 30. That makes me think that it's a VLAN issue. But IP exclusion also makes sense, although I don't think it's called IP exclusion. I think that's called something else. I don't think it's untrusted SSL certificate. I'm gonna go here. Okay, one of them correct. All right, finally one that I've done.
What happens when a topology change notification TCN is received in a network using STP?
So ports may change their status from forwarding to blocking or vice versa. Yes. Next. Oh, I'm going to have to go here in about 20 minutes.
An organization asks a network consultant to assist in learning why the company's network is getting overloaded. Upon monitoring the network, the consultant learns that the CPI utilization of the switches jumps up above 80% at various points. What is happening in the network?
I think it's called a broadcast storm. If it's not broadcast storm, it's multicast flooding. Yeah.
A user has turned in a computer to the help desk with a complaint that nothing works. When the technician logs into the computer, the time is not correct. The technician knows that all domain computers pull time from the domain controller, but this occurs through which protocol?
That's so funny. The complaint is, oh, what's going on with your computer? Nothing works. Cool. I think that it's network time protocol, and I feel so strongly about this. I'm gonna go for it. Yes. Especially because I knew what all those other ones were.
You are unsure if the gateway address is correct for one of your subnetworks because traffic is not leaving the network. Which of the following tables could you look at to check if the gateway address is correct?
The routing table. Yeah. Okay. So it was incorrect time system.
Windows workstations at a small company are not able to log on to a Windows server. Which of the following is the likely cause?
I think that was the one I
A
said was
server or
stupid.
host needs to be configured with the correct time. Authentication and other security mechanisms will often fail if the time is not synchronized on both communicating devices.
Okay. The server and host need to be configured to the same with the correct time. Okay. That makes sense. That goes along with the question we just had.
A computer system sporadically connects to network services. Which of the following is most likely causing this issue?
So okay, let's see what it says. I want to know. Well,
If Windows detects a duplicate Internet Protocol IP address, it will display a warning and disable the IP. Hosts with the same IP will contend to respond to ARP queries, and communications could be split between them. A system with an expired IP address may have lost connection with the DHCP server and will need to have its IP address information updated, and/or lease times should be reduced. A rogue dynamic host configuration protocol DHCP server is one that is distributing addresses to hosts and is not authorized to be on a network. A default gateway is used by a host to find routes to other networks. If a default gateway Internet Protocol IP address is incorrect, network communication will be restricted to the local subnet for the host.
And it said that it sporadically is connecting. So if this was the case, then it would be stuck on the local subnet indefinitely until it was fixed. Okay.
A network engineer is tasked with resolving why certain printers are inaccessible by users next to those printers. The engineer realizes that the printer's network port on the switch is not configured to the proper network. The engineer sets the network configuration tag to 30% for those ports, resolving the issue. What was most likely the cause of the issue?
Okay. Incorrect VLAN. But the big vocabulary word that I don't know is configuration tag. Configuration tag. Okay, printers were on the wrong VLAN. The configuration tag. So configuration tag is the same as the VLAN ID. Okay. So those other systems were just not configured to the same VLAN as those printers. Okay, let's I always enjoy the analogy. Let's look at the analogy.
Imagine an office building with different departments on different floors, and elevators only go to certain floors. If a printer is on floor 3 VLAN 30, but the elevator switch port it's connected to is set to floor 1 VLAN 10, no one from floor 3 can reach it, even if they're physically nearby. Okay. Changing the elevator's floor setting to 3 allows people from floor 3 to access the printer.
You know what that reminds me of? That reminds me of the one level of Banjo-Tooie for the N64 where you're a washing machine and there's like all these different levels to this factory, and there's like different elevators, and certain elevators only go to certain levels and different floors of the overall like thing, and it's really stupid annoying. And out of all of the Banjo-Kazooie and Banjo-Tooie levels, that is literally the worst one and everybody hates it. Okay, that's enough of that. I'm moving on. Cool. All right, understood. Next.
After a sysadmin fixed the configurations of one of the switches, the number of packet collisions dropped to near 0. What setting was most likely contributing to the packet collisions?
Near 0, but it wasn't absolute 0. We only deal with absolutes here.
Half duplex refers to only being able to transfer or receive one at a time. Full duplex refers to being able to transfer and receive at the same time. Having multiple devices configured differently can cause collisions. Memory refers to the component of computers that temporarily stores actively used data. Improving memory would allow larger, more intensive programs to run better.
Bandwidth is the total capacity of the process network traffic, improving bandwidth and improving connecting to the internet. Okay, it makes total sense that it's duplex, speed and duplex. Okay. Next. Broadcast storm. I wanted to know the difference between the broadcast storm and a multicast flooding.
An organization asks a network consultant to assist in learning why the company's network is getting overloaded. Upon monitoring the network, the consultant learns that the CPI utilization of the switches jumps up above 80% at various points. What is happening in the network? What you need to know. A broadcast storm will cause network utilization to go to a near maximum capacity, and the CPU utilization of the switches to jump to 80% or more, making the switch segment effectively unusable until the broadcast storm stops. If a switch is not multicast aware, it will treat multicast transmissions as broadcasts and flood them across all ports in the broadcast domain, consuming much bandwidth and slow down the network. If hosts are experiencing DNS issues, symptoms will include the inability to connect to a server by name, despite being accessible by IP address. The most common reason for a certificate not to be trusted is that the certificate issuer is not trusted.
Floods. So the network is experiencing broadcast storm, which floods the network with repeated broadcast traffic overwhelming the switch. Let's look at the analogy. The analogy always makes sense for me.
Imagine you're in a busy office. If one person sends a group message to everyone every few seconds, and then each person replies to everyone again, you quickly have a non-stop flood of noise. Nobody can get real work done because everyone's dealing with the group chaos. That's a broadcast storm. Multicast flooding, on the other hand, would be like a speaker system meant for just some rooms accidentally being played in all rooms because it wasn't configured right. Great. Let's break.
Okay. So the broadcast storm is everybody. The multicast, well, that makes sense because that's what a broadcast is. And then the multicast is where it's one thing and it's flooding multiple stuff. Okay, understood. Let's keep going. There's only 2 questions that we haven't gone over.
A network administrator is testing a remote server's network configuration and decides to ping the Internet Protocol IP address of a familiar Office Windows workstation. No replies are received, but the admin confirms DHCP settings are enabled on the workstation and can successfully browse the Internet. What is the most likely reason why the client workstation did not respond to a ping request?
The IP address, an IP address from another subnet is being used. The same IP address of another client is being used. No, it's the subnet. That was like the majority of this stream was talking about subnets.
Users are reporting that they are unable to access the company's shared drives within the corporate wireless. However, if they are hardwired, they can access the shared drives. What is the most likely reason that they are having issues accessing the shared drives?
We also talked a lot about DNS today as well. And I still don't fully understand why there's a different DNS when it comes to wireless versus hardwire, but I do understand that it is a DNS issue. And that is wise because they can't, I'm assuming because hardwires, I don't know. I'm gonna have to dive way more into it, but I know that DNS is the issue, is the answer.
You are configuring a new network segment that includes 3 switches, switch A, switch B, and switch C. Switch A is connected to switch B is connected to switch C, and switch C is connected back to switch A, forming a triangle.
It's really forming
to prevent
a circle.
loops, you decide to implement the spanning tree protocol STP. After enabling STP, you notice that one of the links between the switches is not forwarding traffic. Which of the following links is most likely to be in a blocking state due to STP?
Okay, so STP is the spanning tree protocol, which stops looping, packet looping. Because look, let me trust you. Trust me, you don't want packets to be looping. You don't want to be losing. I'm losing packets. Like you don't want to be doing that. You know what I mean? Okay. So there's no way to know because there is no bridge ID. There's no leader. So any of the links could be in the blocking state depending on the bridge IDs.
A network specialist is attempting to troubleshoot an issue where 2 systems are intermittently receiving traffic. In addition to looking for duplicate internet protocol addresses, what could be another consideration for what is causing the problem?
A network specialist is attempting to troubleshoot an issue where 2 systems are intermittently receiving traffic. In addition to looking for duplicate internet protocols, IP addresses, what could be another consideration for what is causing the problem? Duplicate MAC addresses. I'm going big. I'm going for it. Oh, I'm right. Yeah.
In a newly set up branch office, a network administrator configures the network with the subnet 172.116.0.016. All devices are supposed to communicate within this subnet. However, the administrator notices that host X, with the following configuration, cannot access the shared resources located on a server within the same subnet.
It's because the subnet mask is too restrictive. I'll need to go back in and fully understand the math behind subnetting to understand why that 16 is restrictive. But I do understand and know that that is the answer. It's not just because I memorized it. It's because I already have a gentle understanding of subnet. Now, I don't fully understand it yet, but that's the answer.
What might be a symptom of a malicious attack on a DHCP server?
A symptom is going to be not increased speed, frequency changes, address pool exhaustion.
A system is unable to reach any other systems outside of the local subnet. This symptom is characteristic of which problem?
A system is unable to reach any other system outside of the local subnet. This system is a characteristic of what? Is it an incorrect gateway? I really feel like it's an incorrect gateway because that's what we just talked about. There was somewhere up here, it just said that. Yes, it was an incorrect gateway. Because if it has an incorrect gateway, it can only talk to the local. Because it doesn't need the gateway is whatever router that all that crap goes into, so that way they can talk to people outside of the subnet, outside of like basically the intranet. Okay? All right. I knew that.
A user installs a financial software package that requires cloud access. For some reason, the application fails to connect to the cloud server. What is the most likely cause of this issue?
Incorrect host-based firewall settings. Now, how do we know that it's not incorrect time? That's a really good question. Let's talk about it. So a user installs financial software. So he's installed the software and it needs to have access to the cloud. It doesn't insinuate that he doesn't have access to the WAN, just insinuates that he cannot connect to the cloud server. So how do we know it's not the correct time? It's a good question. We'll have to come back to that. My initial thing is because it's a cloud server, and the cloud server and me don't need to have the same time. But if it's an application that is in-house, the application that's in-house and my device need to have the same time.
A system is unable to reach any other systems outside of the local subnet. This symptom is characteristic of which problem?
Yeah, we already did all this. I feel good about it. We're gonna read this and then be done.
Default gateway is used by a host to find routes to other networks. If a default gateway address is incorrect, network communication will be restricted to the local subnet.
Yep.
Recently booted computer systems at a large company are not able to access any network resources. IT investigates and finds the systems configured with automatic private IP addressing APIPA addresses.
APIPA.
Which of the following is most likely causing the issue?
Exhausted HDCP host scope. Yes.
Windows workstations at a small company are not able to log on to a Windows server. Which of the following is the likely cause?
Not UDP ports, incorrect system time. This is what it is. Because it's not able to, because the Windows server is local. Local meaning like within the company. Yes, it's not this. I can't quite remember what ACL means, what an access control list is, but I know that it has nothing to do with this. We gotta relearn that. I need to make my flashcards.
You manage a local area network with several switches. A new employee has started today, so you connect her workstation to a switch port. After connecting the workstation, you find that it can't get an IP address from the DHCP server. You check the link and status lights and see that the connection is working properly. A ping to the workstation's loopback address succeeds. No other computers seem to have the problem. Which of the following is the most likely cause of the problem?
Ooh, we haven't had this one yet. You manage a local area network with several switches. A new employee has started today, so you connect her workstation to a switch port. After connecting the workstation, you find that it cannot get an IP address from the DHCP server. So it might mean that it's running low, doesn't have it, like something, it's exhausted. Okay, you check the link and status light to see if it's correct. Excellent. A ping to the workstation loopback address succeeds. No other computers seem to have this problem. So what was the issue again? After connecting the workstation, you find that it cannot get an IP address from the HTTP server. So half duplex settings on the switch and workstation, incorrect default gateway. Ooh, could be that. Switch looping, incorrect VLAN assignment. I'm going to say that it is the gateway because no, after connecting to the workstation, you notice that it cannot get an IP address from the DHCP server. So it's an issue that it's not getting an IP address, but yet somehow, even though it doesn't have an IP address, I'm assuming it has a puppy, a ping to the workstation loopback address succeeds. No other computers. It's either an incorrect default gateway, which that now no longer makes sense. Half duplex settings on the switch and workstation also doesn't make sense. Switching loop, that kind of makes sense, and so does. Actually, this is the only one that makes sense because the incorrect VLAN assignment doesn't make sense in terms of getting assigned a IP address. Okay, I bet it's this one. Let's check it out.
A sysadmin is monitoring the logs of the network equipment in the corporate office and notices there are a lot of packet collisions. After digging around the individual network boxes, the sysadmin found that there was a misconfigured switch. What setting most likely contributed to the packet collisions?
Duplex, because they were probably
a network engineer is tasked with resolving why certain printers are inaccessible by users next to those printers. The engineer realizes that the printer's network port on the switch is not configured to the proper network. The engineer sets the network configuration tag to 30% for those ports, resolving the issue. What was most likely the cause of the issue?
Configuration tag is the key vocabulary word, which means that it's going to be an incorrect VLAN.
A network technician observes the network nearing
Broadcast storm.
maximum capacity.
I saw 85%. It's broadcast storm. Wow, so it was incorrect VLAN. I'm running out of time, boys.
It's different from the one for the DHCP server and other devices. It's possible that unused ports on the switch were assigned to a VLAN that's different from the one used by other devices.
The most likely caused by the switch port of the VLAN. So the VLAN, it was assigned to a wrong VLAN, so then it couldn't go to the... Still doesn't make sense why I couldn't make it to the DHCP server in order to get an IP address. To me, that's weird. We're going to have to accept that one and keep going because I'm running out of time. I'm going to have to go. I got to go to work.
You manage a local area network with several switches. A new employee has started today, so you connect her workstation to a switch port. After connecting the...
And it's just going to ask me the same thing. It's going to be... I know how this works. Okay, there's like 2 or 3 things in there that we couldn't quite figure out. 92% done. We're going to figure those things out. We got 2 sections left. I feel really, really, really good about it.